Welcome to Beamnda podcast, your frontline source for smart, sharp, and straight talk on IT trends, tech truths, and digital transformation. Here is today's podcast in English.
Welcome to The Deep Dive, the show where we take a stack of information and extract the most important nuggets of knowledge to get you well-informed, fast. Today, we're tackling a challenge that can turn innovation into immediate regret. The dreaded production outage.
Oh, yeah.
You know, what happens when that seemingly minor tweak in your development environment somehow ripples out and bam, breaks everything for your users in production?
Yeah.
It's not just a hiccup, it's business impacting chaos.
It absolutely is. It's the kind of chaos that doesn't just keep IT departments awake at night, but it also, erodes user trust and can bring critical business operations to a grinding halt.
Right.
You're building these incredible tools with Power Platform, right? But without a safety net, every single change carries immense risk.
Absolutely. And the answer, the foundational antidote to that chaos, especially in the lightning-fast world of low-code development, is application lifecycle management, or ALM. Now, you might hear ALM and think, oh, that's just for the seasoned pro coders, the folks writing complex lines of C# or Java. But here's the real insight. ALM is not only applicable, but absolutely essential for low-code and citizen developers using Power Platform too.
That's so true. Think of it this way. Without ALM, your low-code apps might take off like rockets, sure, but they'll likely crash like uncontrolled debris.
Ouch. Yeah.
The true value isn't just about avoiding outages. It's recognizing that ALM transforms citizen developers from just makers of cool apps into architects of scalable enterprise-grade solutions. It's about building responsibly, from day one.
So our mission in this deep dive, drawing extensively from the wealth of insights found in the Beamnda technology training material on Power Platform Application Lifecycle Management, ALM, is to unpack precisely how you can build, deploy, and maintain your Power Platform solutions with consistency, security, and true scalability. Consider this your shortcut to becoming incredibly well-informed on keeping your Power Apps and flows robust, reliable, and, ready for the future.
Yeah, and we're going to explore the core pillars that make this possible. Understanding how to strategically use environments, mastering the different types of solutions, effectively managing configurations with things like environment variables and connection references.
Right.
Implementing robust versioning, leveraging powerful deployment pipelines, and ensuring solid post-deployment governance. It's all about creating a structured, repeatable, and crucially safe path for your applications, no matter how complex they get.
So settle in, get ready to dive deep, and let's bring some much-needed order to your Power Platform universe. Right. We've just touched on the chaos of unmanaged apps. So how do we actually start bringing order to that? It all begins with understanding the core concept.
Right.
What exactly is application lifecycle management in the Power Platform?
Right. Well, at its most fundamental level, ALM is the systematic, structured process of managing your low-code applications. And that means everything from the initial design and development through rigorous testing, smooth deployment, ongoing maintenance, and even, eventually, retirement. And when we say applications, we mean the whole shebang within the Power Platform ecosystem. Your Power Apps, your Power Automate flows, your Dataverse tables, custom connectors, AI builder models, you name it.
That sounds pretty comprehensive.
Yeah.
But how is this different from, say, traditional software development ALM? Power Platform is all about low code, right?
Yeah.
Empowering citizen developers. Doesn't that simplify things, maybe even remove the need for all that structure?
Yeah, that's a crucial and honestly a common misconception. While traditional software development, often with highly specialized pro dev teams, certainly has its own complex ALM practices, Power Platform ALM supports a much broader spectrum of users. You've got citizen developers building solutions for their departments.
Right.
You've got fusion teams combining low code with pro code extensions, and even professional developers working purely within the platform. This blend of user types, paradoxically, makes governance and automation more critical, not less. Without a structured ALM, low-code can quickly become, shadow IT, powerful, yes, but totally unmanageable. The Beamnda technology training material really emphasizes that this structured approach is precisely what transforms low-code from just quick wins into actual enterprise-grade assets.
So it's far from just a nice to have. It's essential for scale.
Yeah.
But for someone just starting, why should they really care? What's the biggest pain point it solves for them right away?
Oh, it's absolutely essential for scalable, secure, and maintainable solutions in today's rapid low-code environment. For that individual maker, it solves the problem of, oops, I broke something accidentally.
We've all been there.
Exactly. For an organization, it prevents issues like configuration drift, where your dev environment and production environment slowly, subtly become out of sync. It enables true team collaboration, and critically, it addresses significant security vulnerabilities. Without ALM, your Power Platform becomes just a collection of individual fragile apps rather than a robust, interconnected system.
That makes a compelling case. So let's talk about the specific benefits that ALM brings to the table. How does it actually deliver on these promises of consistency, collaboration, and security?
Okay, first up, consistency across environments. ALM ensures that whatever you build and test in your development environment moves seamlessly and predictably to your testing and then production environments. This eliminates that dreaded, well, it works on my machine problem,
Yeah.
where an app functions perfectly for the developer but just breaks the moment it's deployed for users. It's about building a predictable release train for your solutions.
And collaboration, that's huge in any modern development effort, especially with these fusion teams popping up everywhere.
Indeed. ALM directly supports team collaboration by enabling multiple developers to contribute to the same solution effectively and, importantly, safely. It introduces concepts like version control and solution segmentation, meaning developers aren't just accidentally overwriting each other's work or introducing conflicting changes.
Right.
It fosters an organized, less chaotic approach, reducing merge conflicts and really enhancing developer productivity.
For the IT professionals listening, I imagine the governance and security aspects are a huge draw, maybe addressing those common fears about low-code getting out of hand.
Absolutely. Through robust features like role-based access control, intelligent environment management, and data loss prevention, or DLP policies, ALM ensures that low-code development aligns with broader enterprise IT standards.
Okay.
This means you can empower your citizen developers to innovate at speed while still maintaining the necessary guardrails for security, data privacy, and compliance. It really bridges that gap between rapid innovation and essential enterprise-grade control.
That's a powerful combination. So what are the actual core components we're talking about here, the foundational building blocks of Power Platform ALM that let us achieve these benefits?
Well, the Beamnda technology training material outlines 3 primary components that act as the backbone. First, we have environments as containers. Think of these as logical, isolated workspaces for your apps, flows, and data. You'll typically have separate environments for development, for testing or user acceptance testing, UAT, and for production. This clear separation of concerns is fundamental. It's like having different workshops for different phases of a project. You wouldn't build a car engine on the showroom floor, right?
No, definitely not. And then there are solutions, those moving boxes we touched on briefly.
Yes, solutions for packaging are absolutely key. They're used to package and transport your Power Platform components, whether that's a Canvas app, a Power Automate flow, a Dataverse table, or a custom connector.
Right.
And there are 2 critical types here. Unmanaged solutions, which you use exclusively during development. They're fully editable and flexible. Think of it as your open toolkit.
Makes sense.
Then there are managed solutions, which are what you use for deployment to testing and production. These are designed for security and control because once imported, their components become read-only and protected, ensuring no accidental changes to your live applications.
So a solution is essentially a neatly packaged collection of everything your app needs to function.
Precisely. And the third core component is deployment automation. This is where tools like Azure DevOps, GitHub Actions, GitLab CI, or even Microsoft's native Power Platform build tools and deployment pipelines come into play.
The automation piece.
Exactly. These tools automate the export, import, and configuration of your solutions as they move through your environments. This dramatically reduces manual errors, increases the speed and consistency of your releases, and ensures that your moving box gets to its destination safely and correctly every single time.
That sounds like a powerful combination. So with these core components in mind, what are the absolute best practices for adopting ALM successfully from the get-go? What should folks prioritize?
Yeah, the Beamnda technology training material provides a clear roadmap, but if I had to pick the most impactful ones to start with, number 1, always use solutions, even for the simplest apps.
Even the tiny ones.
Even the tiny ones. I've seen so many organizations build standalone apps directly in production, only to realize later they can't move them, version them, or manage them consistently. It feels like an extra step initially, maybe, but it saves immense pain down the line.
That makes sense. About building good habits from the start, right?
Exactly. Next, a clear environment strategy is non-negotiable. Define consistent naming, strict access controls for each environment, and stick to them religiously. Without this, you end up with chaotic shadow environments that make governance a total nightmare.
Okay.
And third, track your work in source control, ideally using solution unpacking. While a .zip solution file is great for transport, it's kind of a black box. Unpacking is like taking every single item out of the box and labeling it so you can see every tiny change, every tweak. This becomes a lifesaver for collaboration, granular rollbacks, and just understanding your change history.
So it's really about visibility and control.
Precisely. And finally, automate deployments as early as possible. Manual deployments are slow, they're error-prone, and they're just unsustainable as your Power Platform adoption grows. Automation ensures consistency and speed, allowing you to focus on building great stuff, not repeatedly performing tedious manual tasks.
Let's put this into practice with a real-world scenario, and to make it concrete, let's compare Power Platform ALM to a structured house renovation project.
Yeah.
How does that analogy unfold?
Okay, yeah, I like this one. Imagine the entire renovation process. The ALM planning is like the initial design and blueprint for your house. It defines how you'll approach the entire project from concept to completion, ensuring everyone is aligned on the vision and the process before you even pick up a hammer.
And where does all the messy experimental work happen? The trial and error.
That's your development environment. Think of it as your workshop or garage. This is where you experiment with new materials, build different pieces of the house, maybe make a mess with paint samples, and iterate freely on designs without impacting the actual living space. It's your safe space to innovate and even break things without consequence.
And before the family moves in, you'd absolutely want some form of inspection and walkthrough, right? A sanity check.
Absolutely essential. The test, or UAT, user acceptance testing environment, is your showroom or model home. This is where clients, or in our case, key stakeholders and testers, come to validate the design and functionality. It's a pristine, isolated space separate from the actual living area, where you ensure everything works exactly as intended and meets the requirements before going live.
And finally, the big reveal, the actual live system where people live and work.
That's the production environment, the finished home. This is the live space where everyone lives and interacts. It needs to be stable, secure, and impeccably maintained, with no impromptu construction happening directly inside. It's a place of stability, not experimentation. You want it rock solid.
And the solutions we talked about earlier, those packages, what are those in this house analogy?
The solutions are like moving furniture or specific fixtures. These are the specific sets of items or components you meticulously pack and transport from your workshop to the showroom and then finally to the finished home. They ensure everything fits, functions perfectly, and doesn't damage the existing structure. It's a contained, organized way to move changes without chaos.
That's a powerful way to visualize it. Now, let's use a common scenario. Imagine a small business trying to manage its Power Apps without any ALM. So Sarah from marketing, being proactive, built a brilliant Power App to track campaign leads. Great initiative. But in her urgency, she built it directly in the live production environment. What could possibly go wrong beyond just the immediate app issues?
Oh boy, this is a classic, painful scenario and honestly a common trap for new Power Platform users. When another developer, let's call him John, then tries to update it directly in production, maybe to add a new field or fix a minor bug, he might accidentally break a critical part of Sarah's app.
Right.
But the real issue here is the cascading effect. There's no version history, no testing phase to catch errors, just direct, live changes. If we connect this to the bigger picture, it inevitably leads to instability, not just in that one app, but potentially across the platform. It causes significant rework, and it rapidly erodes trust in the platform itself. Business operations like sales tracking can be directly impacted by these unmanaged changes, leading to lost leads, lost revenue, and endless finger-pointing. It's a nightmare.
Okay, let's bring that to life.
Yeah.
I'll be Dev Clara. Enthusiastic, but perhaps a bit impulsive. Your release manager, David, calm and by the book. Just push that quick fix to the lead tracker app in production. Save the day. It was just a tiny text change, David. Seriously.
Clara, hold on a second. Did you just make a change directly in the production environment? I understand the urgency, I really do, but what about testing? What about our ALM process?
Oh, come on. It was super minor. Just a typo in a label. Didn't think it needed a whole solution, export and import thing. Plus, I was in a hurry to get it out. The campaign was launching.
I get that feeling, Clara. We've all been there. But here's the thing. What if that tiny text change, as you call it, accidentally broke a hidden dependency we weren't even aware of? Or what if a future managed solution update we plan to deploy can't overwrite it properly because of your direct unmanaged change? This is exactly why the Beamnda technology training material stresses using solutions and proper environments for every single change. Our production environment should be like a sealed, protected vault. Every change, no matter how small it seems, needs to come through a managed solution from a properly tested environment. It's not about judging your intentions, it's about protecting the business from unintended side effects and ensuring stability for everyone who relies on that app. Remember the time we had that sales report outage because of an untested quick fix? That wasn't
Guys, slightly. Right.
Yeah.
The sales team was not pleased. Okay.
Yeah, like that.
No more hot fixes directly in prod. Solutions for everything, even typos. You're right. It's about protecting the business, not just my quick fix.
Exactly. That's the ALM mindset, and trust me, it saves us all a lot of headaches in the long run.
So to recap this initial deep dive, ALM is the systematic approach to managing your Power Platform solutions, bringing much-needed order, fostering true collaboration, and enforcing robust security across your low-code development efforts. It's your essential blueprint for Power Platform success. Now, thinking about that blueprint, let's ask our listeners. First, what are the 3 main benefits ALM brings to Power Platform development? Think consistency, collaboration, and word count. And second, why is it a best practice to always build within a solution, even for the simplest apps? What pain does that avoid later? Our memorable phrase for this section, ALM, your blueprint for Power Platform success. So now that we understand what ALM is at its core, let's talk about where all this structure actually lives. That brings us to environments, the fundamental containers of our Power Platform universe. We briefly touched on them, but now we're going to dive much deeper. What exactly is their fundamental purpose and critical role in ALM?
Right, environments. They aren't just empty spaces or folders. They are sophisticated, logical containers for all your apps, flows, connectors, Dataverse data, and custom components. Think of them as distinct, isolated workspaces within Power Platform, each serving a very specific purpose in your application's lifecycle.
And why is that separation so incredibly important? Why not just have one big environment for everything? Seems simpler initially.
Well, because proper planning and separation isolate development activities, control deployments, and critically help you meet your organization's governance and compliance needs without compromise. The Beamnda technology training material emphasizes that environments are a foundational pillar of ALM. They're where the entire application lifecycle happens in a controlled manner.
Okay.
You wouldn't want a developer experimenting with potentially breaking changes to a core data model in the same space where your end users are processing live customer orders, right? That's just a recipe for disaster.
That makes perfect sense. So let's break down the different types of environments. We typically talk about development, test, and production. What are their unique characteristics and appropriate uses?
Okay, let's start with your development environment. This is your sandbox, characterized by its flexibility and freedom. It's designed for rapid iteration, experimentation, and initial integration testing. This is where developers and makers can freely build, modify, and even break apps, flows, and solutions without impacting anyone else. It's your innovation playground, basically.
And the test environment, often called UAT, user acceptance testing.
Yes, often referred to as a test or UAT environment. Its main characteristic is that it closely mirrors your production conditions, same data structure, similar security setup, but it's completely isolated from live users and production data. This separation is absolutely crucial for risk mitigation.
Right.
It's the appropriate place for validating new features, bug fixes, and overall functionality with your key business users and stakeholders, ensuring everything works exactly as intended before it ever touches your live operations. It's the dress rehearsal.
And then the ultimate destination, the production environment, the main stage.
Exactly. The production environment is the most tightly controlled and secure. Permissions are rigorously limited, and there should be absolutely no direct development activities happening here. None. This is where your fully tested and approved applications are deployed for end-user access. It's your live system, designed for maximum stability, reliability, and performance. Think of it as that highly polished main stage where the show goes on without any backstage construction interfering.
So with these different environments, how do roles and responsibilities shift across them? Who does what, where, to ensure the structure is actually maintained?
Clearly defining roles is absolutely essential for smooth operations and preventing chaos. Developers and makers should have full, unfettered access in their development environments to build and innovate. In test, their access might be limited, perhaps to editing only for troubleshooting purposes. And in production, they should ideally have read-only access, or even better, no direct access at all, relying entirely on automated deployments managed by others or systems.
What about the people actually checking the work, the business users, the stakeholders?
Right. Testers or business analysts are granted access primarily to test environments. Their job is to validate functionality, data accuracy, and usability, ensuring the app meets the business need. Admins, on the other hand, are the critical gatekeepers. They manage the environments themselves, enforce security policies, control component modification, and oversee deployments across the board.
Okay.
And finally, end users interact only with production environments. That's where they access the published apps or flows to do their daily work. The Beamnda technology training material emphasizes a best practice here, using security groups, specifically Azure Active Directory roles, for scalable access control. This streamlines permission management and prevents those awful individual user-level headaches.
All right, so with these different types and roles, how do you actually design an effective environment lifecycle? What does that typical path look like for a solution moving through these stages?
A successful Power Platform deployment typically follows a pretty straightforward dev, rate, test, prod lifecycle. Some larger organizations might add pre-production environments for further staging or maybe dedicated training environments, but dev, test, prod is the core. When designing this, a key consideration is whether each project or business unit should have its own dedicated set of environments, or if you'll share them across the organization. Both have pros and cons.
And naming them clearly is probably more important than people realize, isn't it? Avoids confusion.
Crucially important. Use clear, consistent naming conventions like HR Dev, Sales Prod, or Project X UAT for immediate clarity. You also need to define your solution movement paths explicitly, for instance, exporting a managed solution from dev, then importing it into test, and finally promoting the same managed solution to prod. And a vital point here is to actively avoid environment sprawl. Without clear policies, environments can multiply rapidly, leading to increased costs, security vulnerabilities, and just immense confusion. You need processes for cleaning up old or inactive environments and restricting who can create new ones to prevent this chaotic mess.
And finally, let's talk about environment-level security, especially data loss prevention policies, or DLP. This sounds incredibly critical for any enterprise using Power Platform.
It truly is, especially with the explosion of data connectors available now. Security and compliance are paramount at the environment level. Power Platform provides DLP policies to define precisely how data connectors can be used within each specific environment. They act like traffic rules for your data.
How do those actually work? Can you give us an example of a DLP policy in action?
Sure. DLP policies allow you to classify connectors into logical groups, typically business and non-business. You then set rules that restrict how data can flow between connectors in different groups. For instance, you might create a policy that allows data to flow freely between your internal SharePoint and Outlook connectors, both classified as business data, but explicitly blocks any flow of data between SharePoint and a public social media connector like Twitter, classified as non-business data. This prevents sensitive business data from accidentally or even intentionally leaking out of your secure ecosystem.
So different environments can have totally different rules based on their purpose. Like dev might be more relaxed than prod.
Exactly. Environments can be isolated with their own distinct DLP policies, which is incredibly helpful for maintaining compliance with regulations like GDPR or IP, where specific data types might need stricter controls in production than in development. You can use tools like Microsoft Purview or the Power Platform Admin Center to monitor DLP compliance, as well as enforce other environment-specific security controls like encryption, conditional access policies, and comprehensive audit logging.
And beyond DLP, are there other ways to secure environments at this level? Other knobs to turn?
Absolutely. Environment-level security also involves meticulously managing user roles and permissions, applying that least privilege principle. It means carefully limiting the use of premium connectors only where absolutely necessary, and even disabling features like AI Builder or certain HTTP requests in specific environments if they pose an unnecessary risk. It's all about preventing misuse or unintended exposure, maintaining a tightly controlled, secure environment appropriate for its stage in the lifecycle.
Here's where it gets really interesting. Imagine our HR team building a new onboarding app. They can't just build it directly where all the sensitive new employee data lives, right?
Yeah.
So what does this all mean for setting up the right spaces, the right environments for them to work safely and effectively?
Yeah, this raises a profoundly important question. How do we ensure privacy and data integrity throughout the app's creation and deployment, especially when dealing with sensitive HR data? The Beamnda technology training material makes a strong case for a robust environment strategy in this exact scenario.
So what would that look like?
You'd have a dedicated dev environment just for the HR maker to build and iterate. Crucially, they'd pull in sample, non-sensitive data for testing there, never real employee info. Then, when the app is feature complete, it moves to a UAT environment, a near-perfect copy of production in terms of structure, but still completely isolated. Here, a small group of HR managers can test the app with realistic, but again, not live employee data. This meticulous process ensures the app works exactly as intended before it ever touches sensitive production information. And those DLP policies, they act as our digital bouncers for these environments, ensuring, for instance, that HR data never accidentally flows to a public social media connector, even in the dev environment. It's about cultivating secure habits from the very first line of development.
All right, let's bring that to life. I'll be HR Maker Sarah, eager to get things done, and your Power Platform admin Chris, enforcing the rules. Chris, my new survey flow isn't connecting to SurveyWiz. It says, data loss prevention policy has blocked this connection. What gives? I just want to test this new feedback loop for new hires. It seems overly restrictive.
Sarah, I know it can be frustrating initially when you hit one of those, but that's our environment-level DLP policy in action, straight from our Beamnda technology training material guidelines. In our HR dev environment, we've grouped our internal connectors like Dataverse and SharePoint into a business data-only group, and public connectors like SurveyWiz into a non-business group. The policy is designed specifically to prevent any data flow between those groups, precisely to protect sensitive HR information. Even in dev, we want to cultivate secure habits. It's like having a secure wall around our sensitive data, even during construction.
Okay.
We can definitely discuss alternative internal survey tools that are already approved within the business group, or perhaps a different integration pattern if you truly need SurveyWiz, but we simply can't let potentially sensitive employee data mingle with public services even during development. It's a compliance and security must.
Size. Oh, so even though it's just my dev environment, it's still locked down that tightly. I guess that makes sense, really. Better safe than sorry when it comes to employee data, even if it feels like a hurdle right now. Thanks, Chris.
Exactly. It's a proactive measure that safeguards your organization's sensitive information from the very beginning of the development process, preventing potential leaks and compliance nightmares before they even get a chance to happen. Happy to help figure out an alternative.
So to recap this section, a well-planned environment strategy with clearly segmented development, test, and production environments, coupled with well-defined roles and robust DLP policies, is absolutely fundamental for building secure, scalable, and compliant Power Platform solutions. It's all about maintaining that vital isolation for innovation and applying consistent control for compliance. Okay, time for our revision questions on environments. First, describe the primary purpose of a UAT or test environment in the Power Platform ALM lifecycle. What makes it different from dev and prod? And second, how do data loss prevention, DLP policies, help enforce security at the environment level? What kind of risks do they mitigate? And our memorable phrase, environments, isolation for innovation, control for compliance. Okay, welcome back to the deep dive.
We've talked about environments, those essential containers for your Power Platform solutions. Now let's zero in on the solutions themselves, what they are, and why they're so vital to ALM. This is really where your applications take shape and become portable.
Absolutely. A Power Platform solution is essentially a logical container that groups together all the related components of a Power Platform application. Think of it as a meticulously organized shipping container for everything your application needs.
Okay.
From Power Apps and Power Automate flows to Dataverse tables, custom connectors, environment variables we'll talk about later, security roles, even sitemaps, basically everything that makes up your app.
So it's the essential building block for packaging and organizing, almost like a manifest for everything related to your specific app or feature.
Exactly. It's the essential building block for organizing, packaging, and distributing all your app components reliably. In the context of ALM, a solution serves as the primary transport mechanism to deploy these components from one environment to another in a structured and repeatable way.
Right.
It ensures that all necessary dependencies are packaged together so nothing gets left behind or breaks when you move it. Without solutions, you'd be manually recreating or importing individual components one by one, which leads to endless errors and missing pieces. It's chaos.
Now, technology training material makes a really important distinction between unmanaged and managed solutions. This distinction sounds critical, right? Can you walk us through that? Because it seems to trip people up.
Oh, absolutely. This is perhaps the critical concept to grasp in Power Platform ALM. And yeah, it causes confusion. Let's break down. Unmanaged solutions are, as the name suggests, highly editable and flexible. They are designed for use primarily, almost exclusively, in development environments.
Okay, this sandbox again.
Exactly. Developers and makers can freely add, remove, or modify components within them, making iterative changes, experimenting, and debugging. Changes are tracked, sure, but they're not locked in any way, making this the ideal workspace for active development and collaboration. It's your open toolkit.
So the place where you can make a mess and not worry about breaking anything live, it's your drafting board, your workshop.
Precisely. However, and this is a crucial note from the training material, unmanaged solutions are not intended for production deployment as is. They're like that open toolkit, great for building and refining, but not for shipping a final product to a customer or end user. If you deploy an unmanaged solution to production, you lose critical control, integrity, and frankly, future upgradability. It causes major headaches later.
What about managed solutions then? What makes them different and presumably appropriate for production?
Managed solutions are essentially the opposite. They are packaged and finalized versions of a solution. Once imported into an environment, the components within a managed solution become read-only. This is absolutely key for security, control, and stability in your downstream environment.
Read-only, okay.
Yes. They protect the integrity of the application, prevent unauthorized or accidental changes by end users or even other developers in that environment, and ensure consistent behavior across all your testing and production environments.
So these are exclusively for testing and production environments. You wouldn't use them in dev.
Correct. Managed solutions are the only type you should use for deployment to test and production environments. They provide a hardened, version-controlled snapshot of your app that cannot be altered directly without re-importing a new version. This ensures stability, simplifies compliance audits, and significantly reduces the risk of unintentional or rogue changes by downstream users or teams. It locks things down.
This sounds like a great way to protect your live applications. But what happens if you have multiple solutions, maybe updates or perhaps some direct unmanaged changes in one environment? How does Power Platform decide which version to actually use at runtime? That brings us to solution layering, right? It sounds a bit complicated.
It can seem that way, but it's less complicated than it sounds once you visualize it. Power Platform supports solution layering, which basically dictates how multiple solutions containing the same component interact when they exist in the same environment. This is especially important in managed environments where updates must be applied safely and predictably.
Okay, so how does it work?
Each time a managed solution is imported, it essentially adds a new layer above any existing components in the system. Think of it like stacking transparent sheets. The most recent or highest layer takes precedence during runtime.
So it's like stacking transparencies on an old overhead projector. The top one is what you primarily see and interact with.
Exactly that. It's a great analogy. At the very bottom, you have the default system layer, which is the platform's core functionality. Then other managed solutions from Microsoft or third parties might add layers. Now, crucially, here's where the risk comes in. Any unmanaged changes made directly in an environment, that is, changes made outside a solution, also form their own layer, often the topmost one.
Ah, the direct edits.
Yes, the dreaded direct edits in prod or test. These unmanaged changes can easily conflict with or block updates from managed components below them. This is why the Beamnda technology training material strictly advises against making unmanaged changes directly in production environments. If you make a direct change, a new managed solution update might overwrite it, or worse, it might prevent future updates from taking effect properly, thereby compromising the integrity and upgradability of your entire solution. It creates these ghost changes that are hard to track and manage.
So given all this, what are the absolute top best practices for solution management that listeners should implement right away to avoid these pitfalls?
Okay, first and foremost, and I really can't stress this enough, always develop only within a solution. Always. I've seen teams spend days trying to package an app built outside a solution, only to find missing dependencies and broken references. It's a fundamental habit you need to build.
Right from the start.
Right from the start. Second, use unmanaged solutions only in development and never deploy them to shared or production environments. This seems obvious after our discussion, but the temptation for a quick unmanaged deploy is real, especially under pressure, and it almost always leads to long-term pain and technical debt.
So the sealed package is non-negotiable for deployment. Don't ship the open toolkit.
Absolutely. Third, always convert to managed solutions for deployment to test or production. This is your security and consistency guarantor. Fourth, and this goes hand in hand with what we'll discuss later, use solution versioning consistently and rigorously. Semantic versioning, major.minor.patch, tells you immediately the impact of an update. Without it, you're just guessing what changes are in a .zip file, which is a recipe for chaos.
Okay.
And finally, for larger applications, segment your solutions logically. Don't try to put your entire enterprise HR system into one massive solution. Break it down by module, like HR core, leave management, onboarding. This makes maintenance, collaboration, and reuse infinitely easier. Think smaller, logical chunks.
Let's solidify this with an analogy that really brings it home. Comparing solutions to packages being shipped.
Okay, yeah, let's do that. Think of an unmanaged solution as an open package or an open toolbox. You can constantly add, remove, or modify items inside. It's great for assembling and experimenting, perfect for your workshop. You're tinkering, adding new features, maybe pulling some out. But you would never ship a product to a customer in an open package where things could fall out or be tampered with in transit, right?
Right, makes sense. And the managed solution is the sealed product ready for the customer.
Exactly. A managed solution is your sealed package. Once sealed, you can't open it to change the contents without breaking the seal, or rather, deploying a new version. This ensures consistency and prevents tampering during shipping, or in our case, deployment. It's robust, secure, and ready for end users.
And how about the layering we discussed, especially those frustrating unmanaged changes made directly in production? How does that fit the package analogy?
Solution layering is like adding stickers on a box. Each new update, which comes as a managed solution, is like adding a new preferred sticker on top of an old one. The one on top is what you see and use, but the old ones are still underneath. Now, crucially, those unmanaged changes made directly in production after it's been sealed and shipped are like someone scribbling directly on the box with a marker. It might work for a moment, it might look okay, but it can confuse future updates. The next sticker might not stick properly, potentially get ignored or overwritten by the next official update, and create what we call ghost components that are incredibly hard to debug because they weren't part of any official sticker.
That makes it incredibly clear why direct changes are so risky. Now, for a scenario, a development team builds a new expense report app. It has custom forms, complex Power Automate flows, and a custom Dataverse table to store submissions. How do they get this from their, let's be honest, probably messy development area into a clean testing environment and then safely to everyone's production use without breaking anything?
Okay, yeah. If we connect this to the bigger picture, this is precisely where solutions become the team's absolute best friend. In development, the team is working diligently within an unmanaged solution. It's their flexible workspace, allowing them to experiment, debug, and iterate rapidly. They're building all those forms, flows, and tables directly inside it.
Right.
But when it's feature complete and ready for testing, they export it as a managed solution. Think of it as putting all those app components, every form, every flow, every table definition, into a sealed, tamper-proof container. This managed container then goes to the test environment. Once approved there by business users, the same sealed container goes to production.
The exact same one.
The exact same one. This ensures nobody in production can accidentally tweak a button or break a flow. It locks it down, giving you immense stability, full control over upgrades, and a clear audit trail. It's the only safe way to move complex applications.
Let's bring that to life with a role play. I'll be end user Mary, a frustrated user who made a small but important change herself, and you'll be Power Platform admin Alex, trying to explain solution layering patiently. Alex, my special quick print button on the sales app disappeared. I added it myself just last week, directly in the app. What happened? It was so useful for my workflow.
Sympathetically, oh, Mary, I'm really sorry about that. I know how frustrating that can be when something you rely on disappears. We've all been there, trying to make a quick improvement. That disappearance is likely due to something called solution layering.
Solution layering.
Yeah. When we pushed the latest official managed update to the sales app yesterday, following our Beamnda technology training material best practices, it brought its own official version of that part of the app. Your quick print button was an unmanaged change, essentially a custom layer you put directly on top of the live app yourself. The new managed solution, being a higher controlled layer from our development process, took precedence for the main app components. Because your change wasn't part of the official packaged solution, it got effectively overwritten or hidden by the update and didn't persist. This is exactly why we strongly discourage direct changes in production environments. They tend to get overwritten or cause conflicts with our managed deployments, leading to exactly this kind of frustration.
So, my custom button just vanishes. That's incredibly annoying. Is there no way for my custom button to survive these updates? I really need it for my job.
Absolutely there is, Mary. And that's what's truly fascinating here. Understanding the mechanics means we can build things that last. The correct way is for us to add that quick print button to our core unmanaged development solution for the sales app.
Ah, back in development.
Exactly. We'll build it in officially, test it thoroughly, and then package it into the next managed update. That way, it becomes part of the controlled application lifecycle. It's tracked, it's tested, and it will persist reliably across all future managed deployments. It won't just vanish unexpectedly again. We can definitely get that prioritized for you.
To sum up this section, understanding the crucial distinction between unmanaged solutions for flexible development and managed solutions for secure, controlled deployment, and how solution layering works is absolutely fundamental for building secure, version-controlled, and upgradable Power Platform applications. Time for our revision questions on solutions. First, what is the primary difference between an unmanaged and a managed solution, and when should each be used? Think dev versus deploy. Second, explain the concept of solution layering and why making unmanaged changes in production is risky. What problems can it cause? And the memorable phrase for this section. Remember, unmanaged to build, managed to deploy. Welcome back to the Deep Dive. We've talked about solutions and environments. Now let's tackle a common challenge that many of you face, making your Power Platform solutions reusable and adaptable across all those different environments, dev, test, prod, without constantly having to recode or manually change things every single time.
Yeah, this is huge.
This brings us to a topic that unlocks true portability, environment variables and connection references.
These two features are absolutely crucial for solving the perennial hard coding problem in Power Platform. They essentially allow you to make your solutions reusable, environment agnostic, and significantly easier to deploy and maintain. Without them, you'd be constantly editing your apps and flows every time they move from development to test to production, or every time a backend URL or something changes. It's a nightmare.
So why not hard code values? What's the big deal if I just type in the SharePoint URL directly into my flow? That seems faster sometimes.
Well, the big deal is scalability and reliability, especially as things grow. Hard-coding values means that if a SharePoint site URL changes between your dev and prod environments, which it usually does, or if an API endpoint is different in UAT, you'd have to manually go into every single app or flow where that value is used and update it.
Ugh, yeah, that sounds tedious.
It's incredibly time-consuming, highly error-prone, did you miss one, and makes automated deployments almost impossible. Environment variables and connection references streamline deployment pipelines, enforce configuration consistency, and prevent frustrating flow failures due to these mismatches. It's really the difference between a brittle manual process and a robust automated one.
Let's start with environment variables. What exactly are they, and how do they work their magic? How do they help?
Okay. Environment variables are configurable values that are defined within a solution but are designed to store environment-specific data. Think of them as placeholders for values that change between environments.
Like settings.
Exactly, like settings. Things like URLs, email addresses for notifications, specific list or library IDs, or even simple feature toggles like true-false. The Beamnda technology training material highlights them as a core mechanism for your app to adapt to its surroundings without changing its core logic.
How do they actually work in practice? What are the pieces?
An environment variable has a few key parts. A display name, what you see. A schema name, what the system uses, a data type like text, JSON, number, Boolean, and crucially, a default value. This default value acts as a fallback or a value used maybe during development.
Yeah.
But here's the real power. It also has an optional current value that can be defined uniquely for each specific environment after the solution is imported. This separation is what allows that runtime customization. Your app or flow references the variable, not the hard-coded value, and at runtime it magically uses the current value set for that specific environment. This means the app's logic remains constant, but its behavior adapts based on where it's running.
What are some common use cases you see for environment variables? Where do people use them most?
Oh, tons. Storing SharePoint site URLs is a huge one. Dataverse table names, API endpoints for external services, email recipients for notifications, like an admin group email, numeric thresholds for approvals, or even simply a Boolean value to turn on or turn off a new feature without redeploying the entire app. By referencing these variables instead of hard-coded strings, your solutions become incredibly flexible, portable, and much easier to manage over time.
Any important best practices or warnings when using them? Things to watch out for?
Yes, definitely. Always use clear and standardized naming conventions like NVSP site URL or invadmin email so anyone looking at it can immediately understand its purpose. Always include every environment variable as part of the solution package itself, their configuration for your solution so they belong in it.
Right.
And here's a crucial security note, one that's often missed. Environment variables are not for sensitive data. Do not put passwords, API secrets, or confidential keys in environment variables. For those, you absolutely should be using Azure Key Vault or other secure credential stores, which integrate seamlessly with Power Platform. Environment variables are visible to more people, so never store secrets there.
Got it. Secrets going Key Vault.
Okay.
So environment variables handle changing configuration data. What about connection references? What specific problem do they solve?
Okay, connection references are essentially abstract pointers to authenticated connector instances. So think of a SharePoint connection, an Outlook connection, or a Dataverse connection that your apps or flows use within a solution. They point to the type of connection needed.
And their purpose. It seems like my flow just needs to connect to SharePoint. What's the big deal about having a separate reference to it?
The big deal is flexibility in authentication and targeting across environments. They ensure that your solution components remain bound to the appropriate connector context at runtime without requiring manual editing inside each flow or app after deployment. A connection reference includes the general connector type, like SharePoint, a reference name you give it, but importantly, it doesn't contain the specific connection details or credentials itself within the solution definition.
How do they handle moving between environments then? This sounds like where the flexibility comes in.
This is exactly where they shine, and it's a total game changer for ALM. During solution import into a new environment, like test or prod, Power Platform prompts administrators to map each connection reference to an appropriate existing connection for that specific environment.
Oh, well, so you link it up after import.
Exactly. This means you can use a developer's personal account for connections in dev for easy testing, but then map that same connection reference in the solution to a dedicated, secure service account in production when you deploy it there.
Okay, that's clever.
It prevents flow failures due to broken or missing connector bindings, it centralizes connection management, and it simplifies compliance. The Beamnda technology training material strongly advises using service accounts rather than personal user accounts in enterprise environments for production. Why? Because if the personal user account leaves the company or their password changes, boom, your production flows break. A service account provides that stability and security.
So when you deploy a solution, you have to do something specific with both environment variables and connection references after the solution import.
Absolutely. For manual deployments, administrators must review and update environment variable values, the current value, and bind connection references to the correct connections via the Power Platform interface after importing the solution. This is a manual step and honestly a common point of error if people forget. For automated deployments, using tools like Power Platform pipelines, Azure DevOps, or GitHub Actions, these steps can and absolutely should be scripted. The goal is to automate the injection of current values for environment variables and the mapping of connections, ensuring consistency and preventing human error.
That's a clear distinction between how they behave. Any overall best practices here for using both effectively?
Yes. Always include environment variables and connection references inside your solution. Don't leave them orphaned. Set sensible default values for environment variables as a helpful fallback for developers. Use the current value setting to override those defaults specifically for each environment during deployment. Again, avoid personal accounts for connections in production environments, use managed service accounts for reliability and security, and finally, document all environment-specific configurations, or even better, automate their injection during your deployment process to make it foolproof.
Let's use an analogy for these two that I think will resonate. I'm thinking of a smart plug and a universal remote. How does that sound?
Yeah, perfect. Think of environment variables as your universal remote. You design your app, which is like your TV, to receive commands or configurations. The environment variable is the universal remote where you set the specific channel, like a SharePoint URL or an API ID, for that specific environment's TV. The app, the TV itself, doesn't change. Only what the remote points to changes depending on where it is deployed, which room the TV is in. It's incredibly flexible.
Okay, I like that. And the smart plug adapters for connection references.
Connection references are your smart plug adapters. Your flow needs power, or a connection to a service like SharePoint or Outlook. You design your flow with a specific type of plug, which is your connector reference, like I need a SharePoint plug. When you deploy it to a new room environment, you plug it into the correct outlet, the actual connection with the right credentials in that particular environment. The flow, the appliance, is the same, but the way it connects and the credentials it uses changes based on where it's plugged in. It's like having a universal plug that adapts to different power outlets and authentication contexts.
So for a scenario, imagine building an approval flow for purchase requests. This flow needs to send emails from a specific admin account and store documents on a SharePoint site that changes per environment. You have a dev SharePoint, a UAT SharePoint, and a production SharePoint, all with different URLs. How do you manage this without rebuilding the flow 3 times or manually editing it after every deployment?
This is exactly what's fascinating here, and why the Beamnda technology training material highlights environment variables and connection references as the core solution. You'd create an environment variable, maybe call it NV purchase request docs URL, for the SharePoint site URL.
Okay.
In your dev environment, that variable's current value points to dev.sharepoint.com/ASPRD docs. When the solution moves to production, you simply update the current value of that same environment variable to prod.sharepoint.com/HRD docs without touching the flow's logic at all. For the email sender, you'd use a connection reference, maybe Conref in Outlook. In Dev, you map this reference to a connection using your personal Dev account during import. Then, when it's imported into the prod environment, you map that same reference, Conref admin Outlook, to a specific connection that uses the production service account credentials for Outlook. The flow itself remains unchanged, referencing the variable and the reference, dramatically reducing manual effort and potential errors.
Okay, let's do a role play to see this in action, specifically when things go wrong because these weren't set right. I'm developer Sam, frustrated by errors, and your release manager, Rachel, calmly diagnosing the issue. Rachel, the new employee onboarding flow is failing in UAT. It keeps throwing errors about not being able to find the SharePoint list. I swear it worked perfectly when I tested it in Dev just yesterday. This is driving me crazy. What's going on?
Calmly. Okay, let's take a look, Sam. Don't worry, this is a really common one, and it's usually an easy fix once you know what to look for. Did you ensure all your environment variables and connection references were set correctly during the import process into UAT?
I thought so. I just imported the solution.
Our Beamnda technology training material emphasizes this critical post-import step precisely because it's a frequent oversight. My guess is either the environment variable for the SharePoint site URL isn't pointing to our UAT SharePoint site, or, more likely, the connection reference for SharePoint hasn't been remapped to a UAT-specific connection, so it's still trying to connect back using your dev account's credentials, maybe. Remember, these aren't hard-coded within the flow itself. They're external configurations that need to be updated or confirmed for each specific environment after the solution lands there.
Eyes widening, checking a screen. You're absolutely right. Look at that. The SharePoint connection reference was still pointing to my dev account connection. I completely forgot to re-authenticate it or map it to the UAT service account connection after the import. That's what's truly fascinating here, how these small external settings can have such a big immediate impact, and it's so easy to overlook them in the heat of deployment. Wow.
Exactly, Sam. It's a common oversight, especially when you're starting out, but once you understand why they're externalized and need mapping, it becomes second nature during deployment checklists. This is why proper management of environment variables and connection references is so crucial for successful, repeatable deployments. They truly unlock portability and reliability.
So to recap this section, environment variables and connection references are absolutely key for building portable, secure, and maintainable Power Platform solutions by externalizing configurations and abstracting connection details. Now, for our revision questions on this topic. First, when would you use an environment variable versus hard coding a value directly into a Power App or flow? What's the main advantage? Second, why is it a best practice to use service accounts for connection references in production environments rather than personal user accounts? What risk does this avoid? And our memorable phrase, NVARs adapt, connection rest connect. Together they ensure portability. You're listening to The Deep Dive, and we're continuing our exploration of Power Platform ALM. We've laid the groundwork with environment solutions and environment-specific configurations. Now let's talk about how to keep all those moving pieces organized, tracked, and how to ensure your applications evolve gracefully and predictably over time. This is all about versioning and dependency management.
Yeah, versioning is absolutely critical for maintaining structured, reliable, and scalable Power Platform solutions, especially as applications inevitably grow more complex. It's about maintaining order and clarity as things change rapidly in a low-code environment. Without it, you're essentially flying blind with your updates, and you don't know what state your application is in across different environments.
What's the industry standard way to do that? Is there a specific format?
Yes, the standard method and the one recommended is semantic versioning, often called SEMVer. This assigns version numbers in a clear major.minor patch format, like 1.2.0. This isn't just arbitrary numbering. Each part tells you something really important about the nature of the change introduced in that version.
So what does each of those numbers signify for a Power Platform solution? What's the difference between major, minor, and patch?
Okay. A major version change, say from 1.x.x to 2.x.x, indicates a breaking change or a significant overhaul. This might mean changes to an app's core structure, maybe the underlying data model, or fundamental logic that could potentially not be backward compatible with previous versions or other systems relying on it. Big stuff.
Okay, and minor.
A minor version change, like from 1.2.x to 1.3.x, denotes new features or enhancements that are backward compatible. You're adding functionality, improving things, but without breaking existing features or how people use them.
And patches for the small stuff.
Exactly. A patch version change, like from 1.2.0 to 1.2.1, is for small, backward compatible fixes. Think bug corrections, minor UI tweaks, performance optimizations, things like that. No new features, just making the existing stuff work better.
So this helps you immediately know what kind of impact an update will likely have just by looking at the number. That sounds incredibly useful.
Precisely. Maintaining consistent versioning helps developers, administrators, and testers clearly identify which version of a solution is running in each environment. Dev, UAT, production. This clarity also significantly facilitates rollbacks when issues inevitably arise post-deployment. And the platform itself, especially when importing managed solutions, often has built-in checks that prevent overwriting a newer version with an older one, which helps preserve integrity, as detailed in the Beamnda technology training material. It's your historical record and your future roadmap, all rolled into one simple numbering scheme.
Speaking of integrity, applications are rarely isolated islands. They often have multiple components that rely heavily on each other. How do you manage those interconnected pieces, the component dependencies, so that one change doesn't accidentally break something else down the chain?
Ah, yes. You've hit on a huge potential headache, especially in complex solutions. Power Platform solutions are indeed often a web of interdependent components. A Canvas app might use a Power Automate flow, which in turn updates a Dataverse table defined in yet another solution, perhaps. Proper dependency management is crucial to prevent one change from breaking another, and to ensure solutions are truly portable and deployable without errors.
What kind of dependencies are we typically talking about here? What needs to be managed?
There are two main types you need to think about. Internal dependencies are between components within the same solution package, like a flow referencing a table that's also part of that solution. These are usually easier as they travel together. Then you have external dependencies, which are dependencies on components not part of your current solution.
Ah, okay. Like,
This could be a shared custom connector used by multiple apps, an app referencing an entity from a separate common core solution, like a central customer table, or even an external Azure resource, like a Key Vault or an API. The challenge is ensuring everything an app needs is either present in its solution package or reliably available and compatible in the target environment it's moving to.
and how do you manage these effectively to avoid those dreaded missing component errors during import, which can be so frustrating?
Okay. A few strategies. First, adopt a modular solution design. Instead of one giant monolithic solution, organize related components into smaller functional units. For example, a customer management system might have separate solutions for core Dataverse entities, sales process flows, and reporting dashboards. This limits the scope of dependencies within each solution, making them easier to manage.
Break it down. Makes sense.
Second, and this is where the platform helps a lot, ensure all required dependencies are included within your solution when exporting, especially for managed solutions. Power Platform's Add Required Components feature in the solution interface is incredibly helpful here. It scans your solution and automatically pulls in all referenced elements it knows about, minimizing manual oversight and forgotten pieces.
Oh, handy.
Definitely. Finally, for complex external dependencies that the tool might not catch, like dependencies on specific configurations or external systems, document interdependencies clearly. A simple diagram in your documentation or a README file within your source control can save immense debugging time later, avoiding unexpected errors during import or deployment. It's like making sure all the puzzle pieces are in the box and you have the picture on the lid before you ship it.
Now for the moment of truth. What happens when, despite all your best efforts, meticulous planning, versioning, dependency checks, things still go wrong in production? We need to talk about rollbacks and controlled releases. This is the ultimate safety net, isn't it?
Absolutely. This is your ultimate insurance policy. Controlled release strategies are designed to prevent updates from catastrophically disrupting business operations and, crucially, to allow for the safe and predictable reversion of changes when needed. This is especially vital for production environments where a bad solution update can have immediate widespread impacts, leading to lost revenue, compliance failures, or damaged reputation. You need a way back.
What are the common methods for rolling back a problematic deployment in Power Platform? How do you actually undo it?
The Beamnda technology training material outlines a few approaches. The simplest, often manual method is to keep exported .zip files of previous managed solutions. If a new version fails catastrophically, you can simply re-import the previous stable version over the top. It's straightforward, but requires diligent version tracking and manual effort, and might not always work perfectly depending on the nature of the change.
Okay, what else?
A more robust method, particularly for testing major updates before they hit production, is environment cloning. You can duplicate an entire production-like environment, deploy the new version there, test extensively, and only proceed to production if it's stable. This offers risk-free validation but requires available capacity and licenses, so it's not always feasible.
And for organizations with a more mature DevOps practice, something more automated.
For truly robust ALM and rollback capability, you absolutely should use source control for solution XML. This involves storing unpacked solutions, those individual XML files for each component in Git repositories, using the Power Platform CLI or similar tools. The huge benefit here is diff tracking. You can see exactly what changed between any two versions down to a single line of code or a property setting.
Granular visibility.
Exactly. This provides granular component-level rollback capabilities, though it requires a more involved DevOps setup and expertise. The core message, regardless of method, is always have a reliable way to go back to a known good state and practice using it.
So always have a backup plan, know how to use it, and ideally track your changes meticulously.
Precisely. Always maintain backups of your deployed solution packages, especially managed solutions, and version tag them consistently. For those using DevOps, unpacking solutions to source control allows for that granular tracking of component-level changes, which is immensely powerful for precise rollbacks, understanding regressions, and collaborative development.
What about controlled releases themselves? How do you roll things out safely in the first place to minimize the need for a rollback?
Yeah, prevention is better than cure, right? For high-impact solutions, adopt a phased rollout strategy. First, deploy new versions to a pilot environment, or perhaps just a very small subset of trusted users, sometimes called canary releasing. Second, meticulously monitor their behavior using telemetry, application insights, audit logs, and direct user feedback. Only after successful validation and confidence should you promote to broader environments or the entire user base. This minimizes overall risk, ensures quality assurance, and allows you to catch issues early before they affect everyone.
What are the essential tools that help with all of this versioning and dependency management, specifically within the Power Platform ecosystem?
Power Platform provides several key tools. The Power Platform Admin Center is your first stop, allowing you to view solution version history and check component dependencies visually at a high level. Understanding solution layering, as we discussed, is also a tool in itself. It's a mental model you need to master to predict behavior.
Right.
The Power Platform CLI, PAC, is absolutely essential for enabling solution packing and unpacking, which is critical for putting your solutions into source control and automating ALM processes. And for enterprise-grade automation and integrating with wider CI/CD strategies, tools like Azure DevOps Pipelines or GitHub Actions can automate solution imports, backups, version stamping, environment promotion, and much more.
So summarizing the absolute best practices here for versioning and dependencies.
Okay, version every single export consistently, incrementing logically based on Semver rules. Include README files or changelogs within your solution documentation or source control for clarity on what's changed with each update. Always use managed solutions for production to lock components and maintain integrity. And finally, if you can, unpack your solutions into source control using the Power Platform CLI for granular changes, diff tracking, and truly collaborative development. That's the gold standard.
Let's use an analogy here that I think will resonate with anyone who loves to cook.
the recipe book and its ingredients. How does that map?
Great idea. Think of semantic versioning as different editions of a recipe book. A major update, say a new edition, might introduce an entirely new cooking method or cuisine, or could break old recipes because the fundamental approach has changed drastically. A minor update is like adding a new chapter of recipes. You've got new dishes, new features, but all the old recipes still work exactly as written. They're compatible. And a patch update is simply correcting a typo in an ingredient list or clarifying a step for an existing recipe. It's a small fix with no breaking changes, just improving clarity or accuracy.
And the ingredients themselves, those tricky dependencies we need to manage.
The dependencies are like the ingredients required for a specific recipe. A cake recipe depends on flour, eggs, and sugar. If you suddenly update the standard flour definition, maybe a shared component in another solution, to now require a special type of imported wheat that isn't available everywhere, then your cake recipe breaks because a core dependency has changed in an incompatible way.
Oh.
The Add Required Components feature in Power Platform is like the system trying to ensure all your necessary ingredients are listed and packed in your recipe box before you even start baking, ensuring you don't miss anything that recipe explicitly calls for.
Here's where it gets really interesting, applying this. You've got a crucial Power app, maybe the main sales tool, that's constantly being updated. Bug fixes rolling out, new features requested by the team, sometimes major overhauls to integrate with new systems. How do you keep track of what's what, ensure changes don't break existing critical functionality, and crucially, have a safety net if an update goes seriously wrong during peak selling season?
Yeah, this raises an important question about control and safety in a dynamic environment, especially when an application is critical to daily operations. Our Beamnda technology training material stresses semantic versioning for exactly this reason. For example, if you add a new reporting feature to your sales app, you might increment the version from 1.0.0 to 1.1.0. That's a minor version because it's a non-breaking enhancement.
Right.
If you then find a small typo or a visual glitch in that report that needs fixing, that's a 1.11, a patch. But if you completely redesign the underlying data model, perhaps integrating with a new backend CRM system, that's a 2.0, a major version, because it might break older integrations or functionality that relies on the previous data structure. This clear numbering helps everyone, devs, testers, admins, even business stakeholders, know immediately what to expect from an update.
And the safety net.
And crucially, for the safety net, you use tools like the Power Platform CLI to unpack your solutions into source control, like Git. So you can see exactly what changed between version 1.1.1 and 2.00, providing a granular, solid foundation for understanding issues and enabling rollbacks if an update goes sideways unexpectedly. You know exactly what you're rolling back to.
Yeah. Let's do another role play. This is the moment of crisis. A major update has failed. I'm development lead Lisa, stressed out, and your release engineer Mark, calmly executing a rollback because you planned for this. Mark, the 2.0.0 update to the customer portal app is causing blank screens for half our users. We need to roll back NLW. Customer service lines are already lighting up. This is a disaster.
Calmly, decisively. Understood, Lisa. Stay calm. This is precisely why we have our rollback strategy in place, exactly as outlined in the Beamnda technology training material. I've already got the 1.9.0 managed solution package backed up and version tagged in our release repository, ready to go.
Okay, good.
We also have it unpacked in our Git repository, so we know exactly what we're reverting to at the component level, which will help us with the post-mortem analysis later. I'm initiating the import of that previous managed version right now. It will revert the affected components to their last stable state while preserving user data. We'll be back online for those affected users shortly, and then we can analyze what went wrong with 2.0.0 in a non-production environment without the pressure of a live outage.
Exhale sharply. Oh, thank goodness for those version backups and for your planning, Mark. That's truly fascinating here, how absolutely critical that proactive planning and having a solid practice rollback strategy is when things inevitably go sideways in live production. It turns a potential disaster into a managed incident.
Absolutely. It transforms a potential business-stopping crisis into a manageable, albeit stressful, bump in the road. Planning pays off.
So to recap this section, semantic versioning provides a structured, clear way to track changes and avoid compatibility issues, while proper dependency management ensures your interconnected components function seamlessly. Controlled releases and robust rollback strategies are your essential safety net for maintaining business continuity. Time for our revision questions on versioning and dependencies. First, what is the practical difference between a minor and a major version update in semantic versioning? What does each signal about the changes? Second, name 2 different methods for rolling back a problematic Power Platform solution deployment. What are the pros and cons of each? And our memorable phrase, versioning and dependencies, stability and safety in every release. Welcome back to the deep dive. We've covered a lot of ground on Power Platform ALM, from environments and solutions to versioning and managing dependencies. Now let's talk about streamlining that entire deployment process with something truly powerful, something that can really democratize ALM for every maker out there. Power Platform deployment pipelines.
Yes. Deployment pipelines. These offer a Microsoft native and, importantly, low-code alternative to some of the more traditional, complex DevOps practices. They enable visual, secure, and highly controlled solution promotion across your development, test, and production environments, all within the Power Platform itself.
Okay.
It's a potential game changer for many teams because it brings enterprise-grade deployment practices directly into the hands of makers and admins without needing a separate specialized toolset for basic ALM.
What's their core purpose? Is it just about moving solutions from A to B, or is there more intelligence built in?
Their core purpose is far beyond just moving solutions. They aim to streamline deployments, drastically reduce manual errors by automating key steps, foster collaboration within Fusion teams by providing a shared process, and offer an incredibly easy-to-use visual interface with built-in audit trails and approval controls.
Right.
The Beamnda technology training material highlights them as a fantastic way to simplify enterprise-grade deployments, making robust ALM accessible even to teams without deep DevOps expertise or resources.
And who is the target audience for these? Is it just for the central IT department managing everything, or is it truly for the makers themselves?
While IT certainly benefits from the governance aspects, they are especially useful for citizen developers and Fusion teams who want automation and governance without needing complex Azure DevOps or GitHub setups. They empower makers and admins directly within Power Platform to manage their own solution deployments in a structured, governed way. This is a huge step towards true maker autonomy within guardrails.
How do these deployment pipelines actually work? Can you walk us through the typical flow? What does a maker experience?
Sure. They revolve around a straightforward, usually 3-stage model, typically development, test, UAT, and production. Each stage in the pipeline configuration is mapped to a corresponding Power Platform environment you've already set up.
Okay.
Once a pipeline is configured, makers or admins can initiate the promotion of solutions from one stage to the next, using a simple visual pipeline interface directly within the Power Platform Maker Portal or Admin Center.
What are the key steps in that process that users would actually interact with? What buttons do they click?
Well, first, an admin creates a pipeline and assigns your dev, test, and prod environments to its stages. Then, once a maker is ready to move a solution from dev, they initiate the deploy action from their dev environment within the pipeline UI. The pipeline automatically exports their solution from dev.
Okay.
Then, at each subsequent stage, like deploying to test, you initiate the promotion again. The UI allows you to compare changes between the version you're deploying and the version currently in the target environment before you promote it, which is incredibly helpful for catching surprises or unintended changes.
That diff view sounds useful.
It's fantastic. You can also configure mandatory approval, so maybe an admin or a test lead has to explicitly approve the deployment before it can proceed to a critical environment like production, ensuring proper governance. And throughout the process, you can view logs and version history for full traceability of every promotion who deployed what, when, and whether it was approved. The platform automatically handles a lot of the underlying version tracking, dependency checks, and compatibility checks, significantly minimizing errors that often plague manual processes.
That sounds incredibly helpful for reducing human error and adding control. What are some of the core features that really make these pipelines stand out for an organization trying to mature its ALM practices?
Well, they boast a true low-code setup, meaning no coding, no YAML configuration files, no complex scripting is required for basic pipeline setup. Everything is configured directly in the Power Platform Admin Center or even via solutions for pipelines themselves, making it very accessible. They offer a highly intuitive visual UI for drag-and-drop style configuration or simple button-based promotion, which is excellent for makers who aren't DevOps experts. You get clear environment mapping for consistent lifecycle management. A fantastic, often underappreciated feature is that change tracking, allowing you to view diffs between current and new versions of your solution components before deploying, so you know exactly what's changing.
Right.
They include robust approval workflows for adding manual gating of solution promotions, which is key for governance and segregation of duties. And critically for compliance, there's built-in auditing and logging for all deployments and approvals, creating a comprehensive audit trail automatically.
So what are the common use cases and practical benefits here? Where do these pipelines really shine in day-to-day work?
Common use cases include promoting new Canvas app versions smoothly from dev to UAT and then prod, rolling out Power Automate flows to production with mandatory approval checkpoints from IT or a business owner, and validating Dataverse schema updates consistently across environments. They are particularly fantastic for supporting those fusion teams where citizen developers build the core app and IT helps govern the deployment, allowing makers to initiate deployments which IT admins can then review and approve within the same system.
And the key benefits boiled down.
Simplicity is a huge one. No need for complex Azure DevOps, scripting, or PowerShell knowledge for achieving basic, reliable ALM. There's built-in governance through environment separation, approvals, and auditing, which makes IT and compliance teams happy. They're immense time savers, drastically reducing the tedious manual packaging and import-export steps. And they significantly mitigate risk with those built-in dependency checks and version comparisons before promotion, preventing many common deployment nightmares before they happen.
It sounds like they do a lot, and they make ALM much more accessible. But how do they compare to traditional, more powerful DevOps pipelines, like those you can build in Azure DevOps or GitHub Actions? When would an organization still need that full-blown DevOps setup? Is it one or the other?
That's a great question, and the Beamnda technology training material offers a useful comparison. It's often not strictly either. Power Platform deployment pipelines have very low setup complexity because they're UI-driven and require no code for the basics, making them super quick to get started with. Their automation level is moderate, great for solution deployment, but maybe less so for complex infrastructure setup or intricate testing integration. Customization is somewhat limited as the pipeline behavior is fairly standardized around solution deployment. They have that nice built-in 3-stage, or more now, environment mapping and built-in auditing. They're ideal for low-code focused teams, citizen developers, and achieving solid baseline governance where the primary focus is on deploying Power Platform solutions themselves.
And traditional DevOps, how does that stack up?
Traditional DevOps like Azure DevOps or GitHub Actions typically has a higher setup complexity, often requiring YAML, scripting, PowerShell, Bash, and significant DevOps expertise to configure initially. However, it offers a very high level of automation, enabling full CI/CD, continuous integration, continuous delivery, across complex multi-system architectures. Customization is extremely extensive, allowing for custom build steps, complex approval conditions, deep integration with external testing tools, sophisticated rollback logic, infrastructure provisioning, you name it. Environment control is highly flexible, supporting any number of complex environment topologies, but auditing often needs specific configuration within the pipeline itself. These are ideal for advanced ALM scenarios, large enterprise CI/CD strategies, and complex multi-team workflows that involve integrating Power Platform solutions with other pro-code applications, external APIs, automated testing frameworks, or sophisticated security scanning tools.
So it's not necessarily an either situation then. They could potentially complement each other.
Exactly. It's not always one or the other. While deployment pipelines are excellent, maybe even sufficient, for many small to mid-size implementations purely within Power Platform, organizations with more advanced needs, such as multi-region deployments, integrating automated UI or API testing, deep Git integration for component-level source control branching strategies, or integration with Azure Key Vault for injecting secrets during deployment, may still prefer or even combine them with traditional DevOps pipelines. Maybe pipelines handle the core solution deploy, and DevOps handles the surrounding infrastructure or testing. It's about choosing the right tool or combination of tools for the specific job and complexity level.
What are the absolute best practices for effectively using these built-in Power Platform deployment pipelines? How do you get the most out of them?
Okay, first, standardize your environment so each pipeline stage precisely reflects your intended dev UAT prod or similar architecture. Consistency is key. Second, strongly limit direct changes in higher environments like UAT and prod. This is even more critical with pipelines, as direct changes can cause the pipeline's understanding of the environment state to drift, potentially breaking future automated deployments. Let the pipeline manage the changes.
Good point.
Third, always enable approvals for promotions to critical environments, especially production. This provides a vital human governance gate. Fourth, combine them with good solution versioning practices for clear traceability. The pipelines can even help automate version increments. Fifth, and crucially for adoption, train your team, especially makers, on how to use the pipeline UI effectively and, importantly, how to interpret those change tracking diffs during promotion so they understand what they're deploying. Finally, while the pipeline manages deployment, it's still wise to maintain backups of each promoted solution version separately, just in case you need a rollback outside the pipeline mechanism.
Let's use an analogy for Power Platform deployment pipelines that I think will resonate with anyone who's been in a large organization trying to get software released. An automated assembly line in a factory compared to manual work.
Perfect analogy. Imagine a factory. A manual deployment process would be like workers carrying individual parts by hand from station to station, maybe dropping some, grabbing the wrong ones, taking different routes. It's prone to errors, delays, and lost components.
Chaos.
Total chaos. A Power Platform deployment pipeline is like a controlled conveyor belt system. Your solution components move smoothly and automatically from the development station to the testing station with automated quality checks along the way, then safely and consistently to final assembly or production. Each station knows exactly what to do with the component in the right order.
And the approvals we talked about fit in there too.
Absolutely. The approvals are like a quality control manager standing by the conveyor belt with the button. They inspect the component, check the specs, the diff view, and only press the button to allow it to move to the next critical stage. It's a controlled progression, ensuring quality at each gate. And if you were building your entire custom factory from scratch with custom robots and highly configurable stations, that would be your traditional DevOps pipeline. Immense power and flexibility, but a significant upfront investment in design and construction.
So for a scenario, a team is currently struggling with inconsistent deployments due to their manual processes. They waste hours exporting solutions, importing them, then troubleshooting broken connections and misdependencies. It's error-prone and painfully slow. What does this all mean for making that process consistent and automated without needing a full-blown IT DevOps department to set it all up?
Yeah, this raises that important question about efficiency and accessibility for ALM. Our Beamnda technology training material introduces Power Platform deployment pipelines as the perfect solution for this common scenario. Instead of those time-consuming, error-prone manual steps, where developer Sam is pulling his hair out over yet another failed import.
When there.
We've all been there. You define a clear, automated path within the platform itself. Dev, test, prod stages map to your environments. A maker can develop their solution in dev and then, with just a few clicks in the pipeline UI, push their solution smoothly through the predefined stages. The pipeline handles the exporting, importing, versioning checks, dependency analysis, and even pauses automatically for an administrator's or lead's approval before it hits production. It's like having a guided, automated, governed path for your solutions that's built right into the Power Platform, making enterprise-grade deployment practices accessible to everyone, not just highly technical users with specialized scripting knowledge.
Let's roleplay. I'm citizen developer Emily, new to pipelines and a bit nervous about deploying her first app this way. Your IT admin, Ben, guiding her through her first pipeline deployment. Ben, I'm ready to promote my new help desk app from dev to test using the pipeline. This is my first time using it. It looks so simple on the screen, but I'm still a bit nervous I'll mess something up.
Smiling encouragingly. Hey, Emily, you got this. This is exactly what the Beamnda technology training material explains, making ALM easy and approachable for everyone, including makers like you. See that button, deploy to test.
Yeah.
When you click that, the pipeline automatically takes your solution from dev, performs some quick dependency checks, and then, this is the really cool part, it presents you with any changes using that change tracking view. See that? It's showing you precisely what's different between your dev version and what's currently sitting in the test environment.
Oh, wow. Okay. I see the components I added.
Exactly. So you can confirm it looks right. Once you confirm, it initiates the deployment to test. After you and the testers are happy with it in UAT, it will then queue up automatically for my approval before it can go to production. See? No more manual exports and imports for you ever again for this app.
Clicks the button, watching the screen intently. Wow, this is actually really intuitive. The change tracking is truly fascinating here. I can clearly see exactly what I'm moving. This is going to save me so much time and anxiety. Thanks, Ben.
Exactly. It simplifies a complex process, significantly reduces the chances of human error, frees up IT a bit, and give you back more time to focus on what you do best. Building great solutions that solve real business problems. This is governed ALM in action, made easy.
So to recap this section, Power Platform deployment pipelines offer a powerful low-code solution for structured, automated, and traceable solution promotion. They make enterprise-grade ALM accessible and efficient for many teams, empowering makers while maintaining critical governance controls. Let's pause for our revision questions on pipelines. First, what are two key benefits of using Power Platform deployment pipelines over entirely manual deployment processes? Think efficiency and control. Second, when might an organization still choose to use traditional DevOps pipelines like Azure DevOps instead of, or perhaps in addition to, Power Platform deployment pipelines? What kind of advanced needs might require that? And our memorable phrase for this one, pipelines, ALM simplified. Welcome back to the deep dive. We spent a lot of time talking about how to build, test, and deploy solutions effectively using ALM principles. But our ALM journey doesn't just stop when the solution hits production. What happens after your app goes live, after it's in the hands of your users? This is where our final and arguably just as critical section comes in: monitoring, logging, and governance post-deployment.
Yeah, this is a crucial and honestly often overlooked phase of the lifecycle. It's arguably where the true value of your entire ALM strategy is realized or lost. After solutions are deployed, continuous observation and active governance are absolutely essential to ensure ongoing performance, security, and compliance. It's not a one-and-done process. It's about maintaining the health and integrity of your applications over the long haul.
So it's really about proactive oversight, keeping an eye on things, not just waiting for something to break and then reacting.
Precisely. Proactive monitoring prevents minor issues from escalating into major crises. It ensures accountability for all your Power Platform assets. Who owns what? Is it still needed? And it helps enforce policies consistently in the long term, adapting as your organization's needs and the platform itself evolve. You're constantly tuning and refining your live environment based on real-world usage.
What's the central control console for all of this? Where do you start looking to get that overview?
The Power Platform Admin Center serves as your primary hub, your main control panel or nerve center for the platform. It provides core capabilities like monitoring overall environment health. You can see things like API call usage against limits, Dataverse storage consumption, connector usage trends, and active user counts per environment.
Okay.
You can access comprehensive solution and app inventories, showing ownership, modification dates, and activity levels, great for finding out what's actually being used. This is also where you review and configure those critical data loss prevention, or DLP, policies we talked about earlier, and manage security roles for environments and users. Crucially, you can track high-level usage metrics, such as app launches, unique users per app, and error rates, helping you detect anomalies or performance issues at a glance. It's your first stop for operational health.
But the Beamnda technology training material also mentions the Center of Excellence, or COE, starter kit, quite prominently. How does that fit in? Is it just a fancier version of the Admin Center, or does it do something fundamentally different?
That's a great question. It's not just a fancier version. The Center of Excellence, CU Key Starter Kit, significantly enhances and extends the Admin Center's capabilities, often automating things you'd have to do manually otherwise. Think of the Admin Center as your high-level dashboard for the city population, maybe major road traffic. The COE Starter Kit is like adding a sophisticated smart city monitoring system with sensors everywhere, providing a much more comprehensive, customizable suite of Power Apps, flows, and Power BI dashboards that go much deeper into the platform's usage and health.
What are some of its key components that make it so powerful for ongoing governance?
Well, it offers incredibly detailed app and flow catalogs across all your environments, giving you a truly granular inventory beyond what the Admin Center shows easily. It has comprehensive maker activity dashboards to track who builds what, how often, and which components are active versus inactive, helping you identify champions, understand adoption patterns, and nurture new makers.
That sounds useful.
Perhaps most importantly for long-term health, it excels at orphaned resources detection, identifying apps or flows whose owner has left the company. These are often significant hidden security risks and compliance headaches if left unmanaged.
The zombie apps.
Exactly. It also provides automated governance through scheduled flows that can do things like send inactive app reminders to owners, flag potential policy violations like apps using premium connectors without justification, or even automatically archive unused assets after a certain period. And it includes nurture and enablement features like automated welcome emails and training suggestions for new citizen developers, helping foster a healthy and compliant maker community.
So it brings a lot of transparency and automation to the governance side of things, taking the manual burden off admins.
Exactly. It brings transparency, detailed lifecycle tracking, ongoing engagement, and crucially, automation to proactive governance, fostering a healthier, more compliant, and ultimately more manageable Power Platform ecosystem, especially as it scales.
How about actually seeing what's happening at a very granular level? like detailed telemetry, audit logs for security, and specific usage analytics. How do these tools give us that deep insight needed for troubleshooting or compliance?
Power Platform integrates deeply with the broader Microsoft 365 and Azure ecosystem for this. Microsoft 365 audit logs track a vast array of user and admin activities across the platform, including app and data access events, flow executions, start, stop, fail, security role changes, and solution imports or exports. These are accessible via the Microsoft Purview Compliance Center, and for advanced security operations can be ingested into SIEM tools like Microsoft Sentinel for real-time monitoring and threat detection. It's your security camera feed.
And for specific flows when something goes wrong and you need to debug.
For Power Automate, the flow history provides incredibly detailed execution logs for each individual flow run. You can see timestamps for each action, input and output payloads if configured, success failure outcomes, and precise error messages when things break. These are invaluable for troubleshooting, identifying performance bottlenecks within a flow, and understanding exactly why a business process failed.
Yeah.
For Power Apps, usage analytics gives you insights into app launches, unique users over time, session duration, and which apps are most or least used, which helps prioritize maintenance efforts, understand user adoption trends, and make informed decisions about deprecating truly unused apps. And for Dataverse, you can review table-level usage statistics, monitor API call patterns against tables, and analyze plugin behavior via built-in performance metrics and diagnostic logs that can be sent to application insights. It's all about having the detailed data to make informed decisions about health, performance, and security.
This all sounds like a potentially overwhelming amount of data coming from logs and monitors. How do you turn that data into actionable insights? And, importantly, real-time responses when needed?
That's where alerts, policies, and access controls come in, creating a robust enforcement and notification layer on top of the monitoring data. You can set up flow failure alerts using built-in retry settings, or, more robustly, create custom Power Automate flows that monitor the run history of critical flows and notify admins or support teams via Teams or email if repeated failures occur.
Proactive alerting, right?
Exactly. You can also create custom notifications using Power Automate that trigger when certain usage thresholds are exceeded, like API calls nearing limits, or unexpected conditions occur, such as unusually high connector activity from a specific app, routing these alerts for immediate investigation.
And for enforcing those rules we discussed earlier, like DLP, how does that work post-deployment?
Governance policies are key here, and they are enforced continuously. This includes enforcing data loss prevention, DLP policies, to restrict connector usage across environments, which we covered earlier. You can enforce naming conventions for apps, flows, and environments, often automated through CoE kit flows, to ensure discoverability and consistency. And tools like the Solution Checker can be integrated into ALM pipelines to automatically assess solution quality and adherence to best practices before deployment even happens, catching potential issues early.
And finally, access control, making sure the right people have the right permissions continuously.
Yes, access control is crucial for ongoing security. Use built-in environment roles like Maker, User Admin, and leverage Azure Active Directory, AAD groups, for scalable management of user access to apps and environments. The guiding principle here, always, is least privilege. Users should only have the access strictly needed for their role, avoiding the overuse of broad permissions like global or environment admin rights. This drastically reduces your potential attack surface and the risk of accidental or malicious misuse. Regularly review these permissions too.
Let's use an analogy for this whole post-deployment governance picture. The city management dashboard we touched on before. Let's flesh that out.
Perfect. Think of the Power Platform Admin Center as the city manager's office. It gives you that high-level overview, overall population, users, resource consumption, storage, API calls, major infrastructure status, environment health. You see the big picture.
And the CoE Starter Kit, then, is the detailed monitoring system.
Exactly. The CoE Starter Kit is like a smart city monitoring system. It integrates detailed sensors and data dashboards for everything: traffic flow, app usage, utility consumption, connector calls, building occupancy, maker activity, identifying abandoned buildings, orphaned apps. It flags anomalies automatically, identifies areas needing maintenance, and sends alerts to relevant departments, admins, business owners when, say, a water pipe bursts, critical flow failure, or a building is no longer maintained, orphaned app detected. It goes much deeper than the city manager's overview, providing automated insights and actions.
And the logs and telemetry are the raw data feeds.
Those are your public records and detailed event logs. They provide detailed records of almost every action, who accessed which building, app, When, what deliveries were made, data moved, every minor event in the city. When did the streetlights turn on, flow run, who applied for a building permit, new app created. That's your granular audit trail, essential for investigations.
And the DLP policies are the city rules.
Those are your zoning laws and safety regulations. They dictate what types of businesses, connectors can operate where, environments, and how hazardous materials, sensitive data must be handled to ensure public safety and order. They prevent the digital equivalent of a chemical factory being built next to a school, keeping incompatible things apart.
Okay, let's unpack this with a scenario. You've deployed your apps, everyone seems happy, things are running. But how do you ensure they stay healthy, secure, and compliant over time? What if you suddenly see a massive, unexpected spike in API calls hitting your tenant limits coming from one of your Power Apps? What happens next?
Okay, yeah. If we connect this to the bigger picture, this is precisely where post-deployment monitoring and governance become absolutely crucial. Our Beamnda technology training material highlights tools like the Power Platform Admin Center and the COE Starter Kit as your first line of defense. That huge spike in API calls. You'd likely first see it flagged in the Admin Center's usage metrics or get an alert, a big red flag on your city dashboard.
Right.
Then you could immediately dive into the COE Starter Kit's dashboards to identify which specific app, which flow, or maybe even which user is generating those excessive calls. From there, you check the Microsoft 365 audit logs for granular activity around that app or user during the time of the spike. This immediately raises an important question. Is it a legitimate increase due to new successful adoption? Good problem. Or is it a potential misconfiguration? Maybe an infinite loop in a poorly designed flow, or even, worst case, malicious activity. Proactive alerts configured perhaps in Power Automate or via the COE kit could even notify you immediately when such thresholds are crossed, allowing you to investigate and remediate the issue, disable a flow, contact the owner before it significantly impacts performance or security for the entire organization or hits API throttling limits. It's about rapid detection and response.
Let's do one more role play to see proactive governance in action, specifically using the COE kit. I'm governance lead Sarah, proactively using the dashboards, and your IT support Joe, reacting to what Sarah finds. Joe, check this out on the COE Maker Activity dashboard. I found an app flagged by the orphaned objects flow its owner left the company 6 months ago, but the telemetry shows it's still getting like 50 daily launches. Our Beamnda technology training material specifically warns about these hidden risks. This is exactly why we invested time in setting up the COE kit.
Whistle softly. Wow, an orphan app still in active use. That's incredibly fascinating here. And yeah, a huge potential security vulnerability if nobody is maintaining it or even knows what it does anymore. Not to mention, it could just break unexpectedly with the next platform update, causing disruption. Good catch, Sarah. What's our standard process for this one, according to our governance plan?
Right. Our automated governance flow, which we configured as part of the COE kit setup, will immediately send an alert notification to the manager listed for the former owner, or maybe a designated business unit contact, asking them to either claim ownership or approve its archival. If no one claims it within, say, 30 days, we have another flow that flags it for potential deprecation and removal. This is how we ensure accountability, prevent environment sprawl filled with mystery apps, and close potential security holes. It's all about maintaining that long-term operational health and making sure every single Power Platform asset has a clear owner and purpose.
That's a perfect example of proactive, automated governance in action. Using the tools to stay ahead of the curve rather than waiting for things to break or show up on an audit report. Love it.
So to recap this final section, post-deployment monitoring, logging, and robust governance using tools like the Power Platform Admin Center and the enhanced COE Starter Kit, combined with effective alerts and access controls, are vital for ensuring the long-term performance, security, and compliance of your Power Platform solutions. Time for our last set of revision questions, focusing on post-deployment. First, how does the COE Starter Kit enhance the governance capabilities found natively in the Power Platform Admin Center? What extra value does it add? Second, name 3 different types of telemetry or logs you can use to monitor Power Platform solutions after they've been deployed. Think security, performance, usage. And our final memorable phrase, govern your Power Platform. Post-deployment vigilance is key. Wow, what an extensive deep dive into the world of Power Platform ALM. We've really covered a lot of ground today. We've journeyed from understanding what ALM even is, that structured process to manage your low-code solutions from cradle to grave, all the way through designing effective environment strategies, distinguishing between those crucial unmanaged and managed solutions, mastering environment variables and connection references, for true portability.
Yeah, the adapters and remotes.
Exactly. Ensuring robust versioning and dependency management for stability and predictability, and leveraging powerful deployment pipelines like the built-in ones for streamlined, low-code releases.
And we wrapped up with that critical, often overlooked aspect of post-deployment monitoring, logging, and continuous governance. It truly is about bringing control, consistency, and confidence to your Power Platform development efforts. It ensures that your innovations are not just built quickly, which is great, but built to last, scale responsibly, and remain secure in an ever-evolving digital landscape.
So, after unpacking all of this incredible information, particularly drawing on the practical insights from the Beamnda technology training material on Power Platform Application Lifecycle Management, ALM, I have a challenge for you, our listener. What single ALM practice or tool that we discussed today will you commit to exploring or implementing in your own Power Platform environment this week?
Yeah, just one thing to start.
What's the next tangible step you'll take to transform your development process from potential chaos to predictable control? Even a small step makes a difference.
Absolutely. Whether it's finally committing to always building inside solutions from now on, designing a clear naming convention for your environments, investigating setting up the COE starter kit, or simply making sure your environment variables and connection references are correctly mapped in your next deployment. Every single step you take towards robust ALM will make your Power Platform journey more secure, more reliable, and far, far more scalable in the long run.
That's all for this deep dive. We hope you feel incredibly well-informed and empowered to tackle your Power Platform ALM challenges head on. Until next time.